Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's some information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam P on probability. An insurance company issues insurance contracts to two classes of independent lives as shown below, Class A and Class B. Probability of death in Class A is 0.01, in Class B 0.05. Benefit amount is 200 in Class A, 100 in Class B. Number in class is 300 in Class A, and 500 in Class A and 300 in Class B. The company wants to collect an amount in total equal to the 95th percentile of the distribution of total claims. The company will collect an amount from each life insured that is proportional to that life's expected claim. That is, the amount for life J with expected claim E of xj would be K times E of xj. Calculate K. And here's the solution. So let us write X for the random claim for an insured from Class A. Then X equals 200 with probability 0.01 and X equals 0 with probability 0.99. So X is a multiple 200 times of a Bernoulli trial with probability of success P equal to 0.01. Therefore, the expected value of X is 200 times 0.01, which is 2, and the variance of X is 200 squared times 0.01 times 0.99, and that's 396. Similarly, let Y be a random claim for an insured from Class B. Then Y equals 100 with probability 0.05, and Y equals 0 with probability 0.95. This gives E of Y to be 100 times 0.05, so 5, and variance of Y to be 100 squared times 0.05 times 0.95, and that's 475. For Class A, total claims are x1 plus x2 through x500, where x1 through x500 is a random sample from the distribution of x. Thus, these total claims can be approximated with a normal distribution. For Class B, total claims are y1 plus y2 through y300, where y1 through y300 is a random sample from the distribution of y. These total claims can also be approximated by a normal distribution. The sum of these two totals is the amount of total claims, and because this is a sum of two independent random variables, each of which can be approximated with a normal random variable, the sum itself can be approximated by a normal random variable. Let us write T for that sum. Then E of T is 500 times 2 plus 300 times 5, so it's 2500. And also the variance of T, well, we can add variances of all the components that go into T because they're all independent. So that works out to be 500 times 396 plus 300 times 475, and that's 340,500. The company wants to collect the total amount of premiums T such that, note that Z as always denotes a standard normal random variable and phi as its cumulative distribution function, and we are using the continuity correction in this. So 0.95 is the probability that T is less than or equal to T. So T is 95th percentile of capital T, which is the probability of T minus E of T over square root of the variance of T. And note that T itself, the sum of all these individual Bernoulli trial random variables, is discrete. That's the whole point. That's why we should use the continuity correction. So probability that T is less than or equal to T is the same as probability that T is less than or equal to T plus 1/2, less than or equal. That's because if you take less than or equal to T, then t is included, and you can envision a little rectangle around t, centered at t at the bottom, going 1/2 to each side to represent the probability of hitting t if the height of the rectangle is the probability of hitting t, and that extends to the right by 1/2 if it includes t. That's where this continuity correction comes from. It's discussed in detail in my study manual. So this is a probability that t minus e of t over standard deviation of t is less than or equal to t plus 1/2 minus e of t over the square root of variance of t, the standard deviation of t. And that's a probability that z is less than or equal to t minus 2499.5 over square root of 340,500, and that's phi of that number. Of course, from the table, the 95th percentile of a standard normal distribution can be found. I approximated here from the paper table numbers, and it's 1.645. You can actually almost memorize that that's the 95th percentile of a standard normal. It is 1.645. So this t minus 2499.5 over square root of 340,500 must be equal to 1.645. So the t must be equal to 2499.5 plus 1.645 times square root of 340,500, and that's 3,459.3966 approximately. Now, since k times e of t is e of big T is t, that's the way we set it up in the problem, or the problem set it up, we conclude that proportionality constant k for the premium per insured should be k equal to t over e of t, so 3499.3966 over 2500, and that's approximately 1.3838, which is answer E. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the